I have written one Python code. I've written one Python code on centripetal force. So here this is the code. Uh, this is importing from Python, creating the scene. This is the scene. Canvas with 800. With 800 means we are adjusting the screen. Height 600. If I change these values, the height and width of the screen will change. Background color, it can be other also. I can select a white color, okay, blue color, any color I can select. So here, background color is white. Now, scene dot title basically it's like which scene. I mean, on the top of the screen there will be a title, and here you can see circular motion, centripetal versus centrifugal. So here, centripetal, circular motion, centripetal versus centrifugal related. So this is the instruction and this is the output screen. On the output screen, we can see. Then comes to the parameter. Parameter, we are selecting the circular path with certain radius, mass of the rotating particle, and omega is the angular speed. Now coming to the next point, create the central point means at which point we are considering the center. So here the position vector, position is equal to vector which is taken as 0, 0, 0. Okay. So here this is the 0, 0, the center of this. If you divide this screen into 4 segments, this will be like center. And if I change it little bit, because it's three-dimensional, so I can change it. We can it's a three-dimensional figure because I'll show you if I just press the click the right side and try to rotate it. Just a second, I'll switch it. Not working properly, but it can be rotated as well. Here I think there is some mistake little bit. That's why it's not rotating. It's a three-dimensional figure, so we should be able to. Yes, yes. Now it's working. We can make it big, small, and we can turn it also. You can see it's a three-dimensional figure, and that is why coordinate is 0 comma 0 comma 0. The three-dimensional figure, absolutely. Okay, so that is why 0 0 0. Now let's come to radius. Radius 0.2, color equal to color dot red. So the center particle is taken in red color. Then rotating object, the rotating objects information, object, this is space, and then sphere. It's also taken as a sphere, spherical in shape. Position vector 0, radius comma 0 0 because it's a certain distance from the center. Then radius 0.5, color blue, and make the trail. So trail is true. So we are getting a condition actually, and then trail type is point. So it's kind of point. You can see the trail. Its interval is 10 seconds. So in 10 seconds, it is a kind of rotating. So you look at the trail, it's blue in color. Okay, and if it is rotating properly, it should rotate on the blue circle, the boundary. Then we have this create a circular path. The path is created. Okay, and path information is also given the same way. Then centrifugal force is shown as an arrow, and it is in green color. You can see. Okay, colored. So here it actually centripetal force is shown. That's why you are not able to see the green color. But if I switch, here is an option, switch reference frame. So actually we are outside of the frame. That's why centripetal force is the reason actually. Centripetal and centrifugal force are taken from two different perspective, two different place of observation. So if we are seeing from a rest frame, then it is centripetal force. So we are looking at it from outside. So that is why centripetal force. So and that is why towards the center you can see centripetal force is pointing towards the center. And we have toggle switch also. Toggle will do that later. Toggle for the reference frame, rotating frame equal to false. So if we are actually shifting it, okay, and this is a toggle frame, and toggle frame B, where it will be showing the centrifugal as well. Okay, and then else centrifugal arrow dot visible. So we are setting a kind of condition, and the toggle button is also made here below with this instruction. Initialization of centrifugal settings, and then we have like file group where we are actually updating it, and t plus equal to dt. This is kind of updation of time, means it has to be a moving animation. So that is being created by this instruction. And calculator, we need to update the new position, and it has to be continuously calculated. That's why it is in a loop. And we can control the rate. We can make it faster, we can make it slower by changing this rate information. Okay, and then these are just a formula written, because it will be calculating every position, every angle. It will calculate how much is the centripetal force, and accordingly it will uh, give the output on the output screen. Now let's come to the output screen. On this output screen, we can see like it's centripetal force, because we're looking at the rotating object from rest frame, and here it is written also below the diagram. Centripetal force red, and it's shown as a red arrow towards the center. Centrifugal force not shown yet, because we are now in a rest frame, and it's written also inertial or lab reference frame. We are now, this is our current status of frame. Now if we switch the frame, then it will become uh, rotating frame, the observation from rotating frame, that means a non-inertial frame. And let's do that. Now you can see here, current frame is now rotating reference frame, and we can show here the green arrow. Basically, this is the centrifugal force. And when centrifugal force is taken into consideration, centripetal force we should forget. We just think, we shouldn't think about anything about centripetal force when we are explaining in terms of centrifugal. So it's a very helpful visual information of, and information of the centripetal and centrifugal forces. How do they act on an object? And this kind of two different perspectives, and there plays a role of our frame of reference, and it's a three-dimensional figure we can see from any angle. So I hope this animation helps you to understand what is centripetal and centrifugal force. And try to make such animation more, and come back with new animation. Thanks for watching.